So I'm Laura Ormland. I'm with NOAA Fisheries, and I help coordinate citizen science at NOAA along with John McLaughlin. And it's my pleasure today to introduce Dr. Laura Trouille, who is Vice President of Science Engagement at the Adler Planetarium in Chicago. She is also the co-principal investigator for the Zooniverse and a research associate at Northwestern University. While earning her PhD in astronomy at the University of Wisconsin-Madison, and then pursuing her postdoctoral research at Northwestern on the evolution of galaxies, she also fell in love with engaging the public in science. She has been leading the Adler science engagement efforts, including public participation in scientific research through Zooniverse since 2015. And with that, I'm going to turn it over to Dr. Laura.
Hi, everybody. Thank you for the kind introduction. I really appreciate being here. So everybody can see my slides, and it's really a favorite part of my job, working with researchers across the disciplines through Zooniverse. And so I'm hoping this webinar is useful for all of us. As co-PI of Zooniverse, I really appreciate the partnerships we've had with NOAA researchers and the support we've received through NOAA funding. We're extremely excited about the emphasis in NOAA solicitations and strategic planning documents in recent years around the partnerships and opportunities available through citizen science, both for furthering everyone's research, but also for engaging the public. And so this webinar is very much in line with those types of partnership goals. So let's see what more we can do together. So in this talk, I'll first give a brief overview of Zooniverse and highlight a few specific NOAA projects that we've supported to date. We'll then spend much of our time exploring the Zooniverse DIY project builder platform, and then end with the explorations we've been carrying out in integrating machine learning into Zooniverse projects. So Zooniverse today is largest platform for online citizen science. There's over 90 active projects with 2.5 million people around the world. It's kindergarteners to senior citizens who help researchers unlock their data, from discovering planets around distant stars, to marking cell structures for cancer research, to transcribing handwritten historic documents, to tagging chimp behaviors in camera trap video clips, and more and more. So to understand the why of Zooniverse, it helps to know a little of its origins. So back in 2007, there was a group of astronomers that had a 1 million galaxy data set. They quickly realized it would take more than their professional lifetimes to classify all the galaxies, let alone pursue the research questions of interest. So fortuitously, the team was a partnership between the University of Oxford and the Adler Planetarium. So institution with expertise in research and data partnered with an institution with expertise in engaging the public in science. Also at the time, in 2007, Angry Birds was really popular. And so the team wondered, if we put our data online, can we harness the power of the crowd and get reliable results? So in 2007, this Adler Oxford team launched Galaxy Zoo. 150,000 people participated in the first year and contributed millions of classifications. This project has led to dozens of research publications using these data. And the Galaxy Zoo was this first proof of concept within what then became Zooniverse. And it transformed the types of questions that researchers could ask, knowing that there was this reliable solution to unlocking data and unlocking those data sets quickly. Galaxy Zoo also made clear that the public was very much interested in, could definitely contribute meaningfully to real research. So once word of Galaxy Zoo spread through the research community, other researchers with large data sets approached our Adler Oxford team for help. And since 2007, we've built over 450 different citizen science projects, each led by a different research team using the Zooniverse infrastructure. So they all follow a similar model. There's an image or audio file or video clip that needs annotating, tagging, marking, transcribing in some way, and that task is accessible to the general public, and it helps efficiently unlock the data for the researchers. So there are currently 15 active projects on Zooniverse related to NOAA strategic research areas. So each card in this slide represents a different project led by a different research team. The projects cover a range in classification types, so tagging, annotating, transcribing, different subject types. So there's underwater image projects, drone images, satellite images, audio files, video files, and then different partner institutions. So universities, research institutes, government agencies like the EPA, natural history museums, aquariums, and more. So I'll go more into detail in a couple of these in a moment. But first, in addition to those 15 active projects that are currently active on Zooniverse, there have been 30 other NOAA research-related projects to date that we've partnered with. So I'm sharing this slide in part just to give a sense for the breadth of these projects. So here it's we've had a slew of tagging underwater sea creatures projects, a few labeling of cloud and weather images, to transcribing fishery records, to snow and polar projects, to underwater bioacoustic projects, tagging sharks and seals type projects, ocean plastics projects, transcribing historic weather documents type projects. That's just a huge range, and it's the tip of the iceberg in terms of the types of NOAA research-related projects that we could be partnering with and using Zooniverse as a tool for unlocking data. So if we had more time together today, I'd spend the next half hour celebrating like each of these projects, but I've picked two that give a good sense from a NOAA perspective of how citizen science can help propel your research and your impact. So Ocean Eyes is a project led by the NOAA Pacific Islands Fisheries Science Center. So the Science Center is responsible for monitoring fish stocks to help guide fishery management. Their efforts include establishing the sustainable fish harvesting rates for the deep 7 species of bottom fish that are economically and culturally important in Hawaii. So lower down on the landing page for this project, there's this quote from Dr. Richards, who's one of the team leads. The volume of camera data is more than their team alone can analyze. So through Ocean Eyes, the Zooniverse participants assist by marking fish in the images. The team's also using Zooniverse classifications to train machine learning, and that part of the project is just really getting underway. So all with the goal of providing a more accurate representation of deep 7 fish abundance in Hawaii and to support sustainable fishery practices. So here's just a video of the actual task that participants carry out. So it's a marking and labeling task. And you'll see that there's a tutorial tab, there's a field guide tab, there's help text. All of these are different ways to provide participants the information they need to be able to carry out what they're being asked to do, especially being able to recognize the 7 different fish species. That's all really wonderful, like example images in the field guide, in the tutorial, in the help text. So as with all Zooniverse projects, multiple people classify each image. The team then aggregates the results to create a consensus result and a confidence on that result. Many projects use a flat retirement limit. So for example, the first iteration of Galaxy Zoo had 45 people classify every galaxy. So if 44 out of 45 said, hey, I think that's a spiral galaxy, you can be confident in that result. Or if it was a mix of, 10 saying it's spiral, 10 saying it's elliptical, different classifications, you could get a sense that that was a more complicated image and might be something for further review by the team. Ocean Eyes has 15 people classify each image. Where useful, teams can apply sort of a next level of sophistication in their retirement rules by using a piece of our infrastructure called Caesar that watches as classifications come in on a subject, and if there's a clear consensus emerging after some smaller number of classifications, then you can set rules for early retirement. This is what we call our responsive retirement system to even more efficiently use people's time and classification effort. And throughout this talk, I'll refer to this core guiding principle, which is never waste the volunteer's time. So each project has that classification interface, the landing page, help pages, about pages, and then also an associated discussion forum that we refer to as talk. And this is where volunteers engage with each other and the research team around the science and their interests. With so many eyes on these large data sets and humans just this incredible ability to flag the unusual or the weird or the unexpected, it's actually through talk that often major discoveries are made through Zooniverse projects. So like there's this discovery of the presence of zorillas in the Serengeti. And I wish zorilla were a marriage between a zebra and a gorilla, but it's actually this little black and white skunky creature. But it's not something the Snapshot Serengeti team expected to have the presence of this species in their wildlife reserve until a participant tagged one in an image and brought it into the talk forum for discussion. And there's examples like this across all the disciplines of Zooniverse projects, of these serendipitous discoveries of the unexpected or the unknowns. So another NOAA project I wanted to highlight is Stellar Watch. And I wanted to showcase it because it uses our Zooniverse mobile app to do a first very quick triage of images with and without the stellar sea lions present. People just really love swiping right or left for yes or no during their commute or as a way to relax at the end of the day. So our mobile app is this great tool for efficiently doing a first pass at sorting your data in some way. And then the classification task in the regular browser-based experience was to label the images with sea lions whose markings were visible, those kind of identification tags were visible. So the Zooniverse is technologically a really sophisticated platform. It has a powerful API backend, modern JavaScript front end. We host on Azure and then in part on AWS, and it has an ability to scale up to support tens of thousands of concurrent users on any given project or 100,000 across the whole platform at any given time. It also has a whole infrastructure to integrate machine learning alongside human effort. So this investment in a shared infrastructure and transfer of knowledge from projects across all these disciplines on how we're ensuring sort of the robust and reliable data that's being created, also about how to create space for serendipitous discovery and all these different aspects of shared knowledge across the projects. This focus from so many different areas of expertise into a single platform and a shared set of tools has been core to Zooniverse's success and impact and growth. Then there's the aspect that, for example, in both Stellar Watch and Ocean Eyes, each project has received over 1 million classifications from over 10,000 registered participants. There's a huge crowd that comes to each project and a huge number of classifications or science that's done by the public. So it's a huge impact both on unlocking data for research and also on the impact on the participants themselves in terms of attitudes, building trust in science, learning, engagement, and more. And there's so much opportunity through these projects for the type of news articles and social media posts that we want the public to be hearing about. You know, here's how you can get directly involved in climate science, environmental sustainability, in stewardship of our Earth. So I'll read the Twitter quote. I had a fun evening classifying fish with my daughter, Orly, 8 years old, who is an aspiring marine biologist. Thanks, keep up the good work. It's a great story to be able to tell. Here's the impact of our NOAA-funded research efforts and that they're having, and people just like you are directly taking part. So that gives an overview of Zooniverse. I'll pause here to see if there are any questions before diving into the project builder demo and showcase and then talking a bit about machine learning. But if there are any questions so far, I'm happy to take them before I go forward.
Dr. Laura, we do have a question. We have a couple questions. Are there any examples where scientists are feeding live data into Zooniverse where their participant input helps in informing decision making for the mission?
So there's two elements to the question. The first part of, maybe like a live webcam and whether that's flowing in real time into a Zooniverse project. We don't have that. We did an exploration a few years ago with explore.org that has webcams around the world. And we're realizing that at least for the Zooniverse model, there's no need for that synchronicity of like the data happening in real life and then being classified in real time. There's other tools that do that well. So there's no real-time classifications. But the other part of it, of a project being used for policy impact, there's tons of examples. Definitely there's over 400 research publications that have come from Zooniverse projects to date, but there's also Penguin Watch comes to mind, for example, where the data from those drone images of penguins, where you're tagging penguins, they're looking at what are the marine protected areas in the South Sandwich and this Antarctica region. And so the Penguin Watch team was working alongside conservationists and government agencies, and they were able to expand the marine protected area around those South Sandwich Islands based in part on the Penguin Watch data that was coming from Zooniverse participant effort. And actually the Ocean Eyes is another where the data that the Zooniverse participants are creating are helping to set those fishing policies for sustainable fishery practices.
Thank you, Dr. Laura. Do you have time for maybe one more question before we move on?
Yeah, definitely.
Okay. There was one more question. Do you ever have to be concerned about sabotage by anti-climate change activists, or maybe someone who doesn't want to do exactly what is being asked?
It's something we talk about and we very much closely monitor. It is heartwarming and wonderful to see that to date, no. And there's a really robust community of Zooniverse participants in these talk discussion forums. We have moderators who help make sure that the comments are creating a culture of inclusion and welcoming and support. But there aren't that many. We have the ability, to delete comments, but we don't have to do that very much. And I think it's just in large part because of this amazing community of participants and moderators who are just creating this very, very welcoming and supportive space that just doesn't kind of go into the direction that that other negative online spaces can. It's because of very proactive effort by the moderators to set that culture, but also make clear we are here to help and create that space that we're trying to nurture.
Thank you so much. I will let you continue.
The other, from a researcher's perspective, just thinking about another aspect of that question is when classifications come in, you see all the raw classifications, each individual classification, and you can monitor from a given, whether it's somebody who's logged in or even non-logged in participants, they're tagged with an anonymous ID, but you can see the types of classifications they're inputting, and you can put into your data processing pipeline if you find that a particular user or set of users are not inputting good data, whether it's spurious. But that's also very rare in a project to see. But we have sort of aggregation routines that are shared in general, but that also can include that element so that you can check your data to make sure that everybody's kind of coming in good faith. Yeah, it's a good question, both.
Thanks,
right.
Dr. Laura. We'll save whatever questions are coming in now until your next break.
Sounds good. Okay, so the next part is, now that you have a sense for how Zooniverse works and what it enables you to do, let's dive into the project builder and how to use it. So back in 2015, we got funding from the Sloan Foundation and a Google Global Impact Award to democratize access to the Zooniverse infrastructure. The same as we wanted to break down barriers between who can and should do science, we also are interested in making sure that this research tool can be available to anyone for free. So it wasn't just research teams who could get a big grant to support a web developer for 6 months to build a custom project, but instead, really any institution can have access to Zooniverse as a research tool and use it to accelerate their research. So the project builder platform itself is integrated into the rest of the Zooniverse. It's a simple browser-based interface. And as we chat here, I put in yellow the URL, and you are welcome to go check it out, create a test project, and as you're playing around with it, post questions into the chat as well. So here's a screenshot of one of the sections that you fill out. Here, you're inputting text and images for the landing page of the project. This is from one of the projects built by the Cornell Lab of Ornithology team. And then as you build, you can immediately see what your project looks like. So here's the browser-based interface. They input the description, and then there it is as the public-facing landing page. So similar, here's the interface where you set the classification task and you link to your data that you've uploaded through the subject sets tab, and you put in all your help text and accompanying information. And then here's the public-facing view. So you iteratively build, test, and refine, and then immediately see what it will look like to the public as you're building. And then when you're happy with your draft, you click in the visibility tab, apply for review. That kicks off a quick internal review by one of us in the Zooniverse team. So the Zooniverse team, part of the team is here at the Adler Planetarium, and a team at the University of Oxford, and then close collaborators really focused on the machine learning side of things at the University of Minnesota. But one of our internal team does a quick initial review. We give initial feedback and guidance, and then we send it out to our volunteer community of beta reviewers. And I love that over 30,000 of our Zooniverse participants have signed up to be part of that beta review process. Their feedback is critical. They fill out a standard Google form where they can flag aspects that are unclear. They give suggestions on ways to improve. And that direct feedback from your target audience then makes for a project that really works, that really can engage the public that you're wanting to engage. So just the same as you upload your data through the subject sets tab, there's also this data exports tab where you retrieve your classification results. So it's all simple browser-based drag and drop type interfaces. And then for uploading your subjects, especially if you have a larger subject set, like more than 10,000 images, for example, we have a few command line based clients or Python based clients where you can do more automated uploads of data that run in the background. So general design principles. So for this first one, it's a good guiding principle to break down the complex tasks that you might have in mind initially into the simplest components possible so that the broadest population can easily participate. It's just you're keeping your participants' experience in mind as you're building your project. For the second one, I had mentioned before, don't waste participants' time. And this includes using the data that you obtain from the beta test to make sure your aggregation routines are working as expected, and in particular that you're getting the quality of data you need. So how many classifications do you need for each image? You play around with that number through the beta test to see that you don't have way too many people and you're kind of wasting people's time, or too few and you're not getting the quality you need. And you do this before you do your full launch to the public. And then with the design principle number 3, it's the same as this experimentation and iteration principle that you use with your own research. You try, fail, test, refine, iterate as you're building your project, and you're testing it out with friends and colleagues, and then with our beta reviewers to get that feedback to understand, is it working? So you're using these same research skill sets, but in a new context and framing. So the rundown for how to use the Zooniverse Project Builder is you as the research team, you use the platform, the DIY platform, to build your project. Then we, within the internal Zooniverse team, we do an initial review. Then we send it out for community feedback from Zooniverse participants. That beta review tends to last a week, and you get hundreds of people classifying on your project, a little less than 100 people giving feedback through a Google form with survey questions. And then depending on the level of feedback and changes that are needed, it can be as short as a few weeks to a couple months for the research team to refine their project based on that feedback. And then you choose a launch day, you set up all your PR and press, and trying to reach as broad an audience as possible beyond the existing Zooniverse community of these 2.5 million people. And we send an e-newsletter out to the whole Zooniverse community, celebrating and getting them excited about participating in the project. And then you also have as much external communications to get as broad a public as possible interested from the start. And then throughout the lifetime of your project, which can, for some projects, like one we launched last week, it lasted a day because they got 60,000 classifications in one day. And it was amazing for this relatively small nature center to have their entire island critter cam project complete in a day. So some projects last a day, depending on the size of the data set. Some projects last a few weeks. Some projects have lasted, like Galaxy Zoo, since 2007, so we're going on 15 plus years. And so you communicate with your participants via talk, press, and PR, research publications, very much sharing when there's policy impacts, and so on. And so over time, this launch of the Project Builder platform in 2015 just completely transformed the Zooniverse. Prior to that date, we were launching 2 to 3 projects a year as a small web development team, working with individual research teams. And now, over the past 5 years, we've launched over 50 projects every year. So each week, our community of participants are reviewing a new project, and each month, 2 to 4 new projects launch on the platform. And because each project is led by a different research team at different institutions, I think this number is even low. It's more probably like 200 different partner institutions around the world, whether it's research institutions, government agencies, museums, and more different institution types that are using Zooniverse as a tool to unlock their data. So I'm going to pause again here and see if there are any questions about the Project Builder platform, about how people are using it, anything about that part of our process.
Questions? Okay, I see a few questions from last time, but I can ask one of the latest questions. Have teachers, there wasn't a qualification of what grade or level of teacher, but have teachers been inputting their own projects? And do you have any examples of those?
Yes, and it's really fun to see because it's a free DIY, anybody can use it platform. We've had teachers use it from anything from like just within a single class of 3rd graders, just getting the idea of like playing around with data and having just that class or their partner classes across the school classifying on a set of data and then looking at it. Then there's been projects where a teacher partnered with CERN, the Particle Research Institute, high energy particle physics. And so it was a teacher partnered with researchers, but it was really led by the teacher who wanted to, in many ways, have a research experience of her own, but then she engaged her classroom of students in every step of the experience. And they were pulling data from the CERN particle accelerator into this like teacher-led project. And that's such a wonderful example. In the US, there's the Research Experience for Teachers program that teachers can get funding to do that type of experience. And Zooniverse is a great tool. And then there's just the pure example of many, we've had tens of thousands of classrooms use Zooniverse projects, existing Zooniverse projects, for engaging their students in research and science. And they're not using the Project Builder to build their own project. Instead, they're sending their students to Oceanize or to Stellar Watch or to any of the many different projects.
Awesome. I'm not sure how anonymous this is, but for Zooniverse participants, but do you know what the demographics are of the participants?
Yes, so we don't, so when somebody first registers, we don't ask any demographics information at that time. It's just email and create a login, because we don't want that to be a barrier to entry. You can also classify and you don't have to log in. Again, just what's the lowest barrier to entry as possible. But we do surveys of our participants every few years or so. And we just completed a survey from 2021. And there the demographics are, it's about 54% female, 45% male in terms of gender. The age distribution is fascinating for an online science research platform in that it's pretty flat from 17 to 75. It's not like it's mostly retirees or mostly young adults. It's flat across the board there. Around the world, so it's 40% or so based in the US, 20% or so based in the UK, and then the remainder 30 to 40% from all around the remaining part of the world. And so that's also interesting. And each time a research team from a new country, like we have a project that launched not too long ago in astronomy based in Japan, and then all of a sudden we had a whole slew of new Japan-based participants who participated in that astronomy project, but then they learned about all the others. And so you kind of see them going across all the different projects on the platform. In terms of race and ethnicity, Zooniverse tracks, unfortunately, like many citizen science programs, where it is skewed white. And that's an area of active effort for us. So part of our partnerships, for example, a partnership with NASA is about how to engage in thoughtful and equitable ways with more diverse audiences, first starting here in the US and then around the world. But that gives a little bit of a feel for the demographics.
Thank you so much, Dr. Laura.
Yeah.
Are you able to take one more question?
Definitely. Yeah, these questions are great.
Can participants take pictures that feed into Zooniverse, like an event-based Zooniverse?
Yes, I'm glad we came back to this because I wasn't sure whether to mention it earlier. So we have a partnership with citsci.org, and if you're familiar with that platform, that's a data upload platform. You can upload images and different types of data into citsci.org, into your project there. And we've created sort of the back-end infrastructure so that once you've uploaded your images or data there, it can flow into a Zooniverse into a Zooniverse project that you've created for classification of those images or video clips or audio clips. And then the results flow back into citsci.org, which also has some data management kind of elements to it. So that is one way that if you have a project where you're having the public or you're crowdsourcing data collection, whether it's taking photographs or videos or audio, you can crowdsource that data collection through citsci.org and then have it flow into Zooniverse for the crowdsourced classification process.
Awesome, thank you. Okay, and you're ready to continue?
I'm happy to, yes.
Okay, I'll let you go.
So this last section is around the machine learning, some of the experiments we've been carrying out. And whenever it's an audience where there are researchers in the mix or people who have data science backgrounds or that type of expertise, it's a key question that comes up and that we are asking ourselves is, as machine learning and automated routines for image, video, and audio file labeling becomes more sophisticated and capable, what is the role of citizen scientists in the data processing now and into the future? And so, as I mentioned, a key guiding principle for citizen science is don't waste the volunteers' time. So if the machine is good, let's definitely use that. And instead allocate human effort to where our expertise and skills are most useful. And there's multiple areas and aspects of data processing where humans are uniquely suited. So an important one that's a whole talk in itself is the example of a Zorilla from earlier, or if you're familiar with Hannes Voorhoep, which is a school teacher who discovered this amazing supermassive black hole ghost remnant in the Galaxy Zoo project, or just all these moments through Zooniverse of humans, because of our amazing ability to flag the weird, the unusual, the unexpected. They do this like serendipitous discovery of the unknown unknowns. So machines are very good, but they're only as good as the training and input they receive. So one area in citizen science that we know will be useful to keep space for is this human ability for serendipitous discovery of these unknowns, the unexpecteds. And to do that, it's really important to continue to have lots of human eyes on data to catch what the machine may not be looking for or may not know to be looking for. So even in this realm of serendipitous discovery, there are really interesting ways to integrate machines to jumpstart that process, to kind of facilitate humans in that capacity for serendipitous discovery. So that would be a whole other sort of long talk about how to create space for that. What I'm going to focus on here is more broadly where there's a complementarity of expertise between human and machines. And in the next few slides, I'll focus on how we're integrating machines into our Zooniverse infrastructure to carry out the effort alongside humans. And key in this, and one of the last pieces I'll talk about in detail, is that, as you know, humans are complex, and we have to make sure that human engagement is at the core of our design and systems choices. So the first is sort of starting simple, where the general design principle of breaking a complex task into its simplest parts, like taking advantage of our mobile app for the swipe, yes, no, or empty or not task, and then using those responsive retirement rules to more quickly retire images from the system. So rather than waiting until you reach your 15 people to classify every image, if 80% have already agreed by the time you get to a lower number, then you retire the image at that time. But coupled with this breaking down of the complex into simple tasks for human effort is using the initial round of human-generated classifications to train machine learning models to take over that simple task. So for example, there's some recent work in our camera trap projects where you have your machine learning algorithms that can be quickly trained up by a few thousand images specific to a new project, or even transfer learning from an existing project and the machine knowledge that's been gained there to this new project. And then the machine can classify a bunch of the images at high confidence and immediately kind of retire them from the system, especially for these like empty or not images. And then once the machine has enough training images, they can also just completely take over the classification of images with animals as well. And this loop then allows the researchers to efficiently process the rest of their data by using machine effort, and then open up new workflows or research avenues like tagging behaviors that the machines aren't as good at, or have participants just completely move on to a totally new project led by a different team or who are at an earlier stage in the process. And so it's just very much an embracing of the capabilities of a machine to take over at a certain point if the machine is giving the quality of data that you need, and not shying away from that or seeing that as any kind of failure. Instead, it's definitely a signal of a success, because then you can reallocate human effort to where it's most needed. So the next example is where machines are efficient, but in some cases have many. So they're efficient and can create a very complete sample of something you're looking for, but that complete sample includes a lot of false positives, or meaning the machine thinks they found something real, but in fact it's a bogus or false object. So here the example is the Supernova Hunters project, and it's a project where a machine algorithm first sorts through all the images taken by the Pan-STARRS survey each week, and from that, tens of thousands of images, it flags a few thousand as potential supernova, or these are stars that are exploding in the final stages of their life. So each Tuesday, the research team lead for Supernova Hunters would send out an e-newsletter to their participants at 10 a.m. in the morning saying he'd uploaded the data into the project for review, but we always got a kick out of the fact that his volunteers were already in the platform at 9 a.m., knowing that that's actually when he would upload the data. And then in the next few hours, they would give 30,000 classifications, like a tremendous amount of effort by this community of people. And so the whole data set for that week is always retired within a few hours because they really wanted to be, discovering the supernovae of the week. So the human classifications were vetting the machine's initial sense of what was a supernova. But the machine, like I mentioned, in this case, isn't as good as humans at distinguishing real versus bogus, especially for a few specific supernova types. So like bright supernova, the machine isn't very good at identifying because there are fewer bright supernova in the training set. So it's an example of a combination of machine and human effort that gives the most reliable and complete set of supernova for this project. And that's where, depending on your research area and your data type, and depending on what the machines are good at this stage of their development, you can set up the system to just best take advantage of this complementarity of expertise. So the third example is from the Galaxy Zoo project, where we have active learning of the machine model that's integrated into the Zooniverse infrastructure. So the machine knows which image will give it the most new information it needs to be better. So this is the idea of active learning in this field of machine learning research. And so what the machine is doing is it sends into Galaxy Zoo the images it most needs next. The human participants classify those images. It kind of like prioritizes them in the queue, and then the classifications get sent back to the machine. The machine is continuously retraining itself with the images it most needs, and the loop continues. And this makes for a very efficient and increasingly accurate machine model. And instead of the next Galaxy Zoo dataset taking a year or more for humans to classify, it's complete in a matter of weeks because it's both humans and machines working alongside each other. So the final slide kind of in this sequence is about the human engagement side of this, because I can imagine you're all thinking, already probably tuning into possible ways where this breaks down. So imagine how we could keep pushing this in terms of what tasks to allocate to humans. We could just show them the subjects that machines are least confident with, or just show them the ones the machine thinks it knows but just needs to verify, or just show a particular cluster of types of subjects. But something that we and all citizen science platforms know well is that the more engaged your volunteers are, the more data you unlock, the higher your science impact. And into this mix is the fact that humans are complicated, and you have to take in mind what types of tasks engage humans versus which ones do not. So there's this research that Alex Boyer carried out that helps give an example of how the most efficient system between a human and machine can actually detract from the user engagement and in the end make it a very inefficient system. So that's an example of this is the Snapshot Serengeti Blinks experiment that we ran. So at first glance, machines are really good at removing blink images or images where there's no animal present. But it turns out that volunteers will do more classifications of non-blink images, so images with animals in them, if you include a certain number or certain fraction of blinks in the images that they see. So it may be related to how slot machines work, that you'll do more work for an exciting reward. For example, if your first few images have no animals in them, and then you come across this great lion image, that spurs your interest to do more because you think it's a little bit more special to see the lion image. Or it may instead be related to cognitive load and the need for rest. So a simple click to done when you're classifying when there's no animal present and then getting the next image gives you a little rest between the effort of classifying an image with an animal present. So the short of this Blinks experiment and others experiments we've run of this type is that it's just people are complicated and they have motivations and interests to kind of keep in mind. And that humans are definitely more complicated than machines in that sense. And so you need to take into account human motivations and what engages a volunteer when thinking about how best to integrate the machine learning components in a citizen science system. And then optimizing the science relies on optimizing human engagement. So when you're considering integrating machine learning into your citizen science project, it's really key to test out different approaches and evaluate the impact of your choices on your human participants. And part of that process is being fully transparent with your participants about what you're testing and why, and making sure that they are fully aware and in the know as you're testing out these options. So a very different topic, but before I come to just the final closing slide, in a longer or different talk, I would share about how Zooniverse is being used in museums. I'm here based at the Adler Planetarium in Chicago, and we have this amazing Galaxy Zoo-based multi-person touch table experience that's a collaborative experience, and it's just fun to see in person, and we see a huge amount of engagement and impact on our guests through the touch table. But Zooniverse is being used in zoos and aquarium and a lot of natural history museums with their collection items. And if this is an area of interest to you in terms of using citizen science in museum or zoos or aquaria spaces, definitely reach out. I'm really keen to do more in this space of citizen science in museums. And there's an upcoming Citizen Science Association conference in May at Arizona State University. It's part of the annual CSA conference series, and we'll be doing a whole symposium session around citizen science in museums. There's also classroom.zooniverse.org. We have a slew of educational materials for K-12 and college students that were developed by teachers and education researchers over the past 10 years or so. And there's been a recently funded effort that created a series of Geo 101 or an Astro 101 non-STEM major curriculum materials. So if you're interested in that aspect of Zooniverse, of education engagement through citizen science, also definitely reach out to me, and I have my contact info in the last slide. But Zooniverse in museums, Zooniverse in classrooms is just an area of active effort and interest. So I wanted to flag those both. All right, well, thank you for your time today. You are now Zooniverse ambassadors. So the hope is you may see applications within your own research team's efforts, but you may not, and in which case I would really appreciate your help in sharing about these tools with your colleagues, or if you see opportunities where somebody in their research team is doing a task that you think could be crowdsourced and engage the public in that effort, definitely connect them with me. So don't hesitate to reach out, and I look forward to any additional questions you may have.
Thank you so much, Dr. Laura Trouille. We do have a few last questions, and I believe a lot of people are very excited about this. So one of our questions here is there a gamification? And you were kind of talking about this, about the different kind of patterns of putting in blank images, but is there gamification elements to some or all of the projects? So like leaderboards, etc.
There's different experiments we've tried or tested out. It's interesting in the Zooniverse community context, there was an early study in one of our old weather projects, a transcription of ship logs for climate science. And they introduced the concept of a leaderboard and showing publicly different people's classifications. It actually had a negative effect on it was kind of like divided among audience members of who liked it versus who didn't, but the majority of the Zooniverse participants, it was not something they wanted, because part of the principle is that you might only do 1 or 2 classifications, or you may do 10,000, but all of those classifications are key to unlocking that full data set, because we get about half of all Zooniverse classifications come from dabblers, people who only do a few, and half the classifications come from more engaged participants who do many. And if we were to devalue those who only do a few, that's kind of counter to what's actually best for the system overall. But when you go to Zooniverse and you create an account, you can see your personal stats. And there's all sorts of motivations that come from seeing how many classifications you've done, what projects you've participated in, and kind of the pride and motivation that comes from seeing your own stats. And some friend groups and family groups, I know anecdotally share those amongst themselves. And so we have a grant right now to explore the idea of group stats and group challenges, where you say, okay, for this project or across this group of people, you have a 500 classification challenge by the end of January. And then you see as your group is getting closer and closer to that goal. So we have those type of gamified elements, but it's very much, we prefer going the route of kind of community group-based collective efforts to celebrate and motivate versus like pitting individuals. There's also, if you go to gravityspy.org, so Gravity Spy is a Zooniverse project that is testing out what we're calling the leveling up infrastructure, where as you go from simplest tasks to harder tasks, you unlock workflows. So you have to do a certain amount of classifications and effort on the lowest level in order to obtain the higher levels. And that's another way of playing around with the idea of gamified elements in the system. It's a great question. You can tell I'm excited about that area of Zooniverse. And if you have ideas of other things to explore, just very receptive to doing more experiments in that area.
Awesome. There was a comment that throwing up the next image immediately is also a type of gaming. So it's hard to stop when you're seeing a new image.
Yeah.
Good comment from the audience. I think this might be our last question, which is pretty good because we're almost at time. Are there any examples of citizen scientists helping extract details from peer-reviewed papers, like a standardized literature search or meta-analysis?
Oh, that's a good question. We have a project called Astronomy Rewind, where participants go in and are extracting, like segmenting out elements on a page, whether it's the image or the label or the caption, or and that's because it's mainly, in a sense, a transcription project, because those data are not, they're just PDFs, they're not searchable through all the old astronomy journals from decades ago. There's a wonderful project called Science Gossip. Similarly, this was 18th century journals, and going into that project looking for particular elements, especially scientific illustrations. And they found this cool discovery of female scientific illustrators in the 18th century, and that opened up a whole new area of research. It was a great example of serendipitous discovery by having so many eyes on the data. I'll keep thinking about other examples of that type.
No, thank you. We did have another suggestion of doing something like a Wordle model, a challenge per day that is pushed out. So
yes, we love that. Right now, if you go to zooniverse.org/projects, you'll see the current 90 active projects, but we highlight 4 projects in particular. And the idea, kind of the next step of that was like, could we just create just like that idea of just popping up an image, maybe pulling from across all the different projects on Zooniverse and having that as kind of like a Russian roulette experience of Zooniverse.
Great suggestions from this audience today.
Mm-hmm.
I do not see any other questions, so I am going to turn it over to Laura Ormland to kind of wrap up for us.
All right, well, thank you so much, Dr. Laura, to differentiate us, and Katie for hosting this webinar today. I think, I certainly learned a lot, and if you have follow-up questions, we'd be pleased to put you in touch and, talk them over as a community at practice, which I want to remind folks that if you are not part of it already, we have a NOAA Citizen Science community of practice for people who are, who are working for NOAA or affiliated with NOAA, and I'll put my email address and John McLaughlin's email address in the chat in case you want to reach out to us. And with that, I'll just thank Laura again for helping dive into the Zooniverse and helping us understand how we can use it better as an agency. Thank you so much.
Okay, thank you, Dr. Laura. Thank you, Laura Ormlin.